Part 1. Matrix arithmetic with applications to neural networks. Matrix addition. Matrix addition. 2 cross 2 cross 2, 1 plus 5, 6, 2 plus 6, 8, 3 plus 7, 10. Sorry. 4 plus 8, 12. Scalar times vector. Scalar times vector. Scalar times vector. X dash. This is x. X bar. X vector. Here, after this, a coming. So, ax vector. So, equal to a. x1, x2 up to xn equal to ax1, ax2 up to xn. This is scalar times vector. Product of two vectors. Product of multiplication of two vectors. Three ways to multiply. We can multiply by three ways. Element by element, inner product, outer product. Element by element product, Hadamard product. This is column matrix. This is also column. So now we are multiplying a1 b1, a1 b1, a2 b2, element wise multiplication in MATLAB. In MATLAB element wise multiplication only possible. Hadamard product is it is called. This is element by element product. Yeah. Dot product multiplication. This is dot product means inner product, inner multiplication. X dash x vector dot y vector equal to x1. This is the row matrix. This is the column matrix. x1, x2 up to xn, y1, y2 up to yn. Now, this is the inner product. Now we are multiplication x1, y1, x1, y1, x2, y2, x2, y2, xn, y1 plus then xn, y1. This is called a inner product. Another way, here finally, so we got this one. From I to I equal to 1 to n, 1 to n, xi, yi, xi, yi. When here xi equal to x1, yi equal to y1. Here x2, xi equal to x2, yi equal to y2. Here xi equal to xn, yn equal to y, yi equal to yn. So in this inner product, MATLAB inner product uh, inner matrix dimension must agree. Inner matrix dimension must agree. 1 into n into 1. This one with this n with this n. Outer dimensions give size of resulting matrix. Outer dimension give, that is 1 cross 1. 1, 1. That is single row, single column. Single row, only one row is there. Here, number of only one row and with n times. Here, n times with one column. So n into n, 1 into 1. This is the size of the resulting matrix. Dot product geometric intuition. Dot product geometric intuition. Overlap of two vectors. X vector dot y vector equal to x mod y mod into cos theta. Dot product geometric intuition, overlap of two vectors. Where it is going overlap? This is y direction. This is x direction, x vector. This is y vector. In between this angle theta. So in here x for x mod of cos theta. So that's why x y both are mod, then cos theta. This is the overlap of two vectors. Overlap. How much is overlap? In theta. How much theta? Cos theta. This is the overlap. Example, linear feed forward network. Linear feed forward network. R1, R2 up to Rn. Input neurons. Firing rates. R1, R2, Ri, Rn. This one row here. Okay. Linear. This linear feed forward network. Okay. Here in neural network we are saying high layer. Here in mathematically synaptic weights. Output of neurons firing rate. Here actually training going on. Training will happen. So inside for a given input L2 magnitude, the response is maximized. When the input is parallel to the weight vector, reciprocative field also can be thought of this way. This is R, this is the omega. So R omega, already we have seen, no? Say, cos theta. In between theta, cos theta. Okay. Okay. Inside For a given input L2 magnitude, the response is maximized when the input is parallel to the given input L2 and the response is maximized when the input is parallel to the weight vector. Here, how much weight? Weight vector when the input is parallel to the weight vector. Reciprocative fields also can be thought of this way. Reciprocative fields also can be thought of this way. Okay. Multiplication, outer product. Multiplication, outer product. Here, n cross 1 matrix. That is n times of column. One column. N times of element with one element. One in one column. This is column matrix. This is row matrix. Row matrix. Here, one row. This is the one row and up to m elements. Here, n elements, one column. First row will come, then column. After multiplication, this is outer product. So, n and m we are going to multiplication. Up to n. N, m. So, x1, y1, x1, y1, x1, y2, x1, ym, x2, y1, x2, y2, x2, ym, up to xn, y1, xn, y2, xn, ym. This is called n cross n. Yeah, already what we have seen this simulation instruction. Note each column or each row is a multiple of others. Each column, here each column, this one column, this one column. This is here each row. Multiplier two of the others. Multiplier of the others. Matrix times vector. Matrix times vector. Matrix times vector. Matrix times vector. What matrix times vector? Y vector equal to W x vector. Y equal to W x1. Here m cross n1, m cross n, n cross 1 matrix. This is column matrix, one column matrix, m cross n, row and column. Here column matrix. Matrix times a vector. Matrix times a vector. Inner product interpretation. Rule, the ith